In our previous sessions, we learnt about different laws of exponents and powers. We also learnt about the standard form of numbers. In this session, we will learn more about them. We know how to express large numbers in the standard form. Now, how about small numbers such as the number shown here? This number can also be expressed in the standard form. In order to do that, let us first write this number as 6 by 10 raised to the power 8 as shown. Using notations of negative exponents, this number can again be written as 6 into 10 raised to the power of minus 8, which is in the standard form of a number. We know that a number is said to be in the standard form if its decimal number is between 1.0 and 10.0, including 1.0 multiplied by an exponent of 10. Now, let us consider a number, say 0.00015. This can be written as 15 by 10 raised to the power of 5 as shown, which can again be written as 15 into 10 raised to the power of minus 5. However, according to the definition, standard form of a decimal number should be between 1.0 and 10.0. For this, we can write 15 as 1.5 times 10 times 10 power minus 5. On simplification, we get 1.5 into 10 raised to the power of minus 4, which is in the standard form. We have learnt about the standard form of a number. Let us now try and solve some problems using this knowledge. The size of RBC is 8 times 10 raised to the power of minus 6 meters and the size of a plant cell is 1.275 into 10 raised to power minus 5 meters. Find out which one is bigger and by how many times. Given the size of the RBC is 8 times 10 to the power of minus 6 and the size of a plant cell is 1.275 times 10 to the power of minus 5. From here it is obvious that a plant cell is bigger than the RBC, but to find out how many times, we have to take the ratio of these measurements. On simplification using the quotient law, we get 8 over 1.275 times 10 power minus 1, which is approximately equal to 6 into 10 raised to the power of minus 1, or simply 0.6, which means the size of the RBC is 0.6 times the size of a plant cell. Let us solve one more problem. Find the mass of the helium atom, which has 2 protons and 2 neutrons, if mass of a proton is 1.672 times 10 raised to the power of minus 27 and mass of the neutron is 1.674 times 10 raised to the power of minus 27. Let us list the given information as shown. We know that the mass of the helium is equal to the mass of 2 protons plus mass of 2 neutrons, which is equal to the expression shown. Before adding numbers in the exponential form, just check whether they are in the standard form or not, and then check whether they are multiplied by the same multiple of 10. Here, both the numbers are in the standard form and they also have the same power to the base 10. Then we can simply add their decimal numbers as shown. On multiplying with 2, we get the mass of the helium atom as 6.692 into 10 raised to the power of minus 27. Now, we know how to add two numbers in the standard form. Let us see how we can subtract numbers in the standard form. The distance between the Sun and the Earth is 1.496 times 10 raised to the power of 11 meters and the distance between the Earth and the Moon is 3.84 times 10 raised to the power of 8 meters. During the solar eclipse, the Moon comes between the Earth and the Sun. At this time, what is the distance between the Moon and the Sun? Let us list down the given information as shown. To calculate the distance between the moon and the sun, we have to subtract the distance between the earth and the moon from the distance between the earth and the sun. Now, it is not possible to subtract it directly because the powers of 10 are different in the numbers. First, let us make these powers equal using the product law as shown. On multiplying 1.496 with 1000, we get 1496. Now, the powers of 10 are the same in both the numbers and it can be subtracted as shown. We get the answer as 1492.16, which is the distance between the moon and the sun. This can also be written as 1.49216 times 10 raised to the power of 11 in the standard form. Let's quickly recap what we learned so far. We learned the method of expressing small numbers in the standard form. We also learned how to compare, add, and subtract two numbers in the standard form. That's all for now. I'll see you in the next session. Till then,